Good morning, student. Welcome back to revisions class. Right. So in the last class we discussed about the electric potential. Right. So expression for the electric potential at a point due to a point charge. Right. So in that same take one, that is electric potential due to a dipole. Right. So here we are going to find the relation for the electric potential that is due to the dipole. So dipole is the two equal and opposite charges separated by a small distance, right? So first consider one dipole, right? So that means consider two charges. So taken one is minus q and another one is plus q, right? So these two charges are separated by a small distance. So that is 2a and O is the center of the dipole, right? So we are going to find the electric potential at any point in the space near to the dipole. So your dipole is there. So anywhere you can find the electric potential, right? So for that we consider one point, right? So that is point P. So we are going to find the potential at point P due to this dipole, right? So this point P is at a distance r from the center of the dipole. So that means that is at a distance r. So a point P is to distance that is from the distance r from the center of the dipole, right? So here we are taken the point P is at a distance from plus q charge is r1, right? So same wise the point P at a distance r2 from minus q charge, right? So the dipole moment is always from minus to plus charge. So this gives what the dipole moment, that is from negative charge to the positive charge, right? So from the center of the dipole, the plus q charge is at a distance a from the center of the dipole, the negative charge is at distance a, right? So this is a diagram. So consider one dipole, equal and opposite charges separated by a small distance, so that distance is 2a. So where O is the center of the dipole, so consider any point P at a distance r from the center of the dipole, which makes an angle theta with the dipole moment. So the angle is another, we consider that as the theta. So theta is the angle which is made by the line joining point between the center of dipole and to the point P along with the dipole axis, right? So or dipole moment, right? So potential at a point P. So potential at a point due to two individual charges, that is one due to plus q charge and the potential due to minus q charge, right? So that we taken V, that is equals to V plus q plus V minus q, right? So we know the relation for the potential 1 divided by 4 pi epsilon naught q divided by, so due to plus q charge, so distance is r1, right? Plus 1 by 4 pi epsilon naught potential due to minus q charge. So here we taken minus q divided by the distance is r2, right? So in these two terms we can take 1 by 4 pi epsilon naught q as common. So remaining is 1 by r1 minus 1 by r2. So calling this as the first relation, right? So from geometry, so we need to find the distance r1 in terms of r. So ನಮಗೆ ಇಲ್ಲಿ r1 ಮತ್ತೆ r2 ಇದೆ. So ಈ ಎರಡು ಟರ್ಮ್ ನ ರಿಪ್ಲೇಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ with the distance with respect to r and a. So r ಮತ್ತೆ a terms ಅಲ್ಲಿ we are replacing the distance perpendicular because directly we can take square plus r square, but ಇಲ್ಲಿ ನಮಗೆ ಇದು perpendicular ಇಲ್ಲ, so it makes some angle theta, right? So again from the geometry, so we can write r1 square is equals to r square plus a square minus 2a or cos theta, right? So that is the resultant, right? So So from this relation, we can take r square as common. So 1 plus a square by r square minus 2a divided by r cos theta. Right? So this distance r is very greater than a. So as r is very greater than a, so hence this term is neglected. So a square by r square ಅನ್ನೋ term ನ ನಾವು ಏನು ಮಾಡ್ಕೋಬಹುದು, neglect ಮಾಡ್ಕೋಬಹುದು, right? So r1 square is equals to r square 1 minus 2a divided by r cos theta, right? So we need 1 by r1. So first remove the square. So that means by taking the square roots on both sides. So r1 is equals to r into 1 minus 2a by r cos theta. So it is simple mathematics, right? So mathematics steps is that. So ಇಲ್ಲಿವರೆಗೂ afterwards so ಇದಿಷ್ಟು ಏನಾಗುತ್ತೆ ನಮಗೆ ಮ್ಯಾಚ್ ಆಗುತ್ತೆ. ಸೊ ಇವಾಗ r1 ಬಂತು. ಸೊ ನಮಗೆ ಬೇಕಾಗಿರೋದು ಯಾವುದು 1 by r1. So by taking reciprocal, right? So 1 by r into 1 minus 2a by r cos theta. So ಇದು ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲೇ ಇರುತ್ತೆ, ಬಟ್ ಪವರ್ ಏನಾಗುತ್ತೆ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ಪ್ಲಸ್ 1 by 2 ಇದ್ರೆ ಇದು ಏನಾಗುತ್ತೆ minus 1 by 2, right? So now by expanding this with the binomial theorem, so binomial theorem use ಮಾಡ್ಕೊಂಡು ಇದನ್ನ ಸೀರೀಸ್ ನ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡ್ರೆ we get the relation r1 is equals to 1 by r 1 plus a by r cos theta, right? So again we getting minus 2a by r divided by 3 factorial into cos theta. So and so on terms. So divided by factorial ಅಲ್ಲಿ terms ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗೋದ್ರಿಂದ so higher terms ಏನು ಮಾಡ್ಕೊಂತೀವಿ ನಾವು ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂತೀವಿ. So we can write only this one. So 1 by r1 is equals to 1 by r into 1 plus a by r cos theta. So ನಮಗೆ 1 by r1 ಬಂತು. So similar wise we can simplify, then we get 1 by r2, right? So that is r2 square is equals to r square plus a square plus 2ar cos theta, right? So ಇಲ್ಲಿ ನಮಗೆ ಮೈನಸ್ ಇದೆ, ಅಲ್ಲಿ ಪ್ಲಸ್ ಇದೆ. Why? Because so this becomes 180 degree, right? So 180 minus theta. So ಈ angle ಎಷ್ಟಾಗುತ್ತೆ 180 minus theta, right? So cos of 180 minus theta ಏನಾಗುತ್ತೆ ನಮಗೆ cos minus theta ಆಗುತ್ತೆ. So minus into ಏನಾಗುತ್ತೆ ಪ್ಲಸ್ ಆಗುತ್ತೆ. So hence we return r square plus a square plus 2ar cos theta, right? So same way simplify ಮಾಡಿದ್ರೆ we get 1 by r2 that is equals to 1 by r into 1 minus a by r cos theta, right? So further is to simplification necessary iralla. So just change with 1 plus a by r cos theta iradena 1 minus a by r cos theta, right? So now substitute these two values, right? So equation 2, equation 3. So substitute equation 2 and 3 in equation 1, right? So equation 2 ಮತ್ತೆ equation 3 ನ ಯಾವಾಗ substitute ಮಾಡಬೇಕು ಅಂದ್ರೆ equation 1, right? So that is what the potential due to the dipole, right? So V is equals to Q divided by 4 pi epsilon naught into, right? So 1 by r1. So 1 by r1 ನ ಏನು ಬರೆಯಬಹುದು 1 by r into 1 plus a by r cos theta, right? So again minus 1 by r 1 minus a by r cos theta. So here the term only 1 by r common is there. So V is equals to 1 divided by 4 pi epsilon naught q divided by r. So 1 plus a by r cos theta minus 1 plus a by r cos theta, right? So minus 1 plus 1 get cancelled. So here two similar terms ಇರೋದ್ರಿಂದ a by r cos theta plus a by r cos theta ಏನಾಗುತ್ತೆ 2a by r cos theta ಆಗುತ್ತೆ, right? So 1 divided by 4 pi epsilon naught q divided by r into 2a divided by r cos theta, right? So V is equals to 1 by 4 pi epsilon naught 2a cube cos theta divided by r square. So this is the final expression for the potential due to the dipole, right? So ತುಂಬಾ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಏನಿಲ್ಲ, ಬಟ್ ಯು ನೀಡ್ ಟು ರಿಮೆಂಬರ್ ದಿಸ್ ಫಾರ್ಮುಲಾ. ಸೊ ಇದು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಜಿಯೋಮೆಟ್ರಿಯಲ್ಲಿ ಬರುತ್ತೆ. ಸೊ ಆ ಫಾರ್ಮುಲಾನ ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ಸೊ ಇದು ನೆನ್ಪಿಟ್ಕೊಂಡು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ವಿ ಗೆಟ್ ದ ಈಕ್ವೇಶನ್ 2. ಸೊ ಸಿಮಿಲರ್ಲಿ ಅಂತ ಬರ್ಬಿಟ್ಟು ವಿ ಕ್ಯಾನ್ ರೈಟ್ ದ ಈಕ್ವೇಶನ್ 3. ಸೊ ಈ ಫಾರ್ಮುಲಾ ಬರೆಯದಲ್ಲೇ ಇದ್ರೂ ಕೂಡ ವಿ ಕ್ಯಾನ್ ಡೈರೆಕ್ಟ್ಲಿ ರೈಟ್ ಆಫ್ಟರ್ ದಿಸ್, ರೈಟ್? So similarly we can write 1 by r2 is equals to 1 by r into 1 minus a by r cos theta. Now substituting the values of 1 by r1 and 1 by r2, right? Only by r1 value na itkondu e substitute ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ so further long ಆಗುತ್ತೆ. So directly first we need to find 1 by r1. So 1 by r1 value na find out ಮಾಡ್ಕೊಂಡು substitute ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ ನಮಗೆ ಈಜಿ ಆಗಿ ಸಿಗುತ್ತೆ, right? So this is the potential due to a dipole. So in another form we can write 1 by 4 pi epsilon naught p cos theta divided by r square. Why? Because p is equals to 2a q. That is from the definition. Dipole moment is equals to product of the magnitude of the charge and the distance between the charges. So dipole ಅಂತ ಕೇಳಿದ್ರೆ ಒಂದು ಪ್ಲಸ್ q charge ಮತ್ತೆ ಇನ್ನೊಂದು ಮೈನಸ್ q charge ತಗೊಂಡು potential at a point due to dipole, right? So simple, but simplification mele importance for it, right? Move on to the next question. Derive sigma is equals to n square tau by m, where symbols having their usual meanings, right? So this is from current electricity, that is conductivity. So conductivity is the reciprocal of the resistivity, right? So sigma is equals to 1 by rho. So here we are going to find the value of rho. So question number 4, right? Sigma is equals to n e square tau by m, right? So tau is the relaxation time or mean free path time, right? So consider one conductor having the length s cross section a, right? First we need to consider one conductor. So conductor ಗೆ length ಎಲ್ಲಿ ಇರುತ್ತೆ, ಜೊತೆಗೆ ಏರಿಯಾ ಆಫ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್. ಸೊ ಇದನ್ನಂತಲ್ಲ, ಇನ್ ಬಿಟ್ವೀನ್ ಎಲ್ಲಿ ಬೇಕಾದ್ರೂ ತಗೊಂಡ್ರು ಕೂಡ ಅದು ಯೂನಿಫಾರ್ಮ್ ಇರೋದ್ರಿಂದ ವೇರ್ ಎ ಇಸ್ ದ ಏರಿಯಾ ಆಫ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್, right? So this conductor consists of the charge carriers. So here the charge carriers are the electrons. So conductor ಅಲ್ಲಿ charge carriers ಯಾವುದು electrons ಇರುತ್ತೆ, semiconductors ಆದ್ರೆ holes ಮತ್ತೆ electrons ಎರಡೂ ಇರುತ್ತೆ. So ಇದು ಕಂಡಕ್ಟರ್ ಆಗಿರೋದ್ರಿಂದ charge carriers ಎಲ್ಲ ಯಾವ್ದಾಗಿರುತ್ತೆ ನಮಗೆ electrons, right? So electrons are the charge carriers, right? So now conductor, this conductor is connected to the external source, that is external potential, right? So ಈ conductor ನ ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, external source ಗೆ connect ಮಾಡ್ತಾ ಇದೀವಿ. So which having the potential V. So when it is connected to the external potential, the current is flowing in the conductor. So current starts to flow in the conductor. That means the electrons gets accelerated and drifted, and it starts to move with the velocity, that is the drift velocity, right? So this is about the diagram and explanation, right? So first we consider one conductor which having the length L and area of cross section A, right? So this conductor consists of the electrons as the charge carrier. So conductor ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವಾಗಲೂ charge carriers ಯಾವುದು ಇರುತ್ತೆ, ನಮಗೆ electrons ಇರುತ್ತೆ. Now connect this conductor to the external source which having the potential V. Then current starts to flow in the conductor and the electrons gets drifted. So electrons ಎಲ್ಲ ಏನಾಗುತ್ತೆ, ಮೂವ್ ಆಗೋದಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, right? So that means the electrons gains the acceleration, right? So that means initially the electrons are at rest. When we connect it to the external potential, the electrons gets accelerated. That means it changes its velocity from 0 to velocity. So that velocity is the drift velocity, right? So first, so this is the given question, right? So first, volume of the conductor, right? So volume of the conductor, so area into length. So volume ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವಾಗಲೂ area into length ಅಥವಾ area into height, so ಯಾವುದನ್ನು ಬೇಕಾದರೂ ತಗೋಬಹುದು, right? So volume of the conductor here, A is the area of cross section and L is the length of the conductor, right? So total number of charge carriers in the conductor. So ಎಷ್ಟು volume ಅಲ್ಲಿ ಎಷ್ಟು number of charge carriers it consists means, so that is Q is equals to N E A L. So ಎಷ್ಟು volume ಅಲ್ಲಿ number of charges, that means number of electrons. So charge is denoted by Q, that is equals to N E A into L, right? So when we connect it to the external potential, so current, that is current I is equals to Q divided by T. So T is the relaxation time, right? Number of charges flowing per unit time. So ಈ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ number of charges, ಈ cross section area ನಲ್ಲಿ ಎಷ್ಟು electrons cross ಆಗುತ್ತೆ per unit time ಗೆ ಅನ್ನೋದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, current ಅಂತ ಕರಿತೀವಿ. So Q ಗೆ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿದೆ, right? So that means N E A L divided by T. So where L is the length of the conductor, so E end ಇಂದ E end ವರೆಗೂ electrons move ಆಗ್ತಾ ಇದೆ with the time T, which having the velocity Vd, right? So that means Vd is equals to L divided by T, right? So I is equals to NEA Vd. So distance by time, that we call as the velocity. Now shift the area into LHS, that goes to the denominator I divided by A, that is equals to NE. So replace the value Vd. So Vd ಗೆ ನಮಗೆ drift velocity value ಗೊತ್ತಿದೆ. So that value is E tau divided by m, right? So ಇದು 3 marks ಅಲ್ಲಿ derive ಮಾಡ್ಕೊಂಡಿದ್ವಿ drift velocity. So E by m gives what, the acceleration into time. So initial velocity 0 irutte, so final velocity is the drift velocity. So that velocity is E tau divided by m, right? So I by A, V density J, right? So that is equals to E square tau divided by m into E. So again E is also vector, right? So calling this as the first, right? So compare equation with standard equation, right? So compare equation 1 with current density J is equals to rho into E, right? So LHS ಅಲ್ಲಿ current density J ಇದೆ. So first equation ಅಲ್ಲೂ LHS ಅಲ್ಲಿ current density J same as it is, right? So next RHS ಅಲ್ಲಿ vector E ಇದೆ. So first equation ಅಲ್ಲಿ ಕೂಡ vector E ಇದೆ. So only the replacement is, so rho place, that means sigma place ಅಲ್ಲಿ ಏನಿದೆ ನಮಗೆ n square tau by m, right? So therefore rho that is equals to, sorry, sigma that is equals to n square tau divided by m. So this is the final expression for the conductivity, right? So in case of resistivity we need to take this reciprocal, right? So rho is equals to m divided by n square tau, right? So simple derivation, tumba sara keliro derivation, right? So you need to practice. So it is very simple, right? So next, obtain the expression for effective EMF and effective resistance of two cells connected in, so first one is parallel and the second one is series. So question number 5, effective EMF and effective resistance when connected in. So in that first one, so yavude namage parallel, right? So that means two cells which are connected in right? So two cells consider the two cells. So first cell is E1, which having the EMF E1 and internal resistance R1, right? So consider another cell of EMF E2 and internal resistance R2, right? So now these two are connected in parallel, right? So taken these points as A, B1, B2 and this point C, right? So I is the current which is flowing in the cell. So I and current ಏನಾಗ್ತದೆ ಈ ಎರಡು combination cells ಅಲ್ಲಿ flow ಆಗ್ತಿದೆ at the junction B2. So from the Kirchhoff current law at the junction B2, so current divides. So cell E1 ಅಲ್ಲಿ current I1 flow ಆಗುತ್ತೆ. So cell E2 ಅಲ್ಲಿ current I2 flow ಆಗುತ್ತೆ. Right, so current ಏನಾಗ್ತಿದೆ divide ಆಗ್ತಿದೆ ಎಲ್ಲಿ, that is at the junction B2, right? So from Kirchhoff current law, right? ಅಲ್ಲಿ KCL ಅಂತ ಬರೀತೀವಿ. So Kirchhoff current law, I that is equals to I1 plus I2. So call this one as the first relation. So regular ಆಗಿ ಮುಂಚೆ ತುಂಬಾ ಸಲ ಹೇಳಿದೀನಿ, the potential across parallel. So parallel ಅಲ್ಲಿ potential ಎಲ್ಲಾ ಕಡೆಗೂ ಏನಿರುತ್ತೆ ನಮಗೆ ಸೇಮ್ ಇರುತ್ತೆ. So the potential across the EMF E1 that is equals to the potential across the cell E2. So ಈ ಎರಡು ಸೆಲ್ ಅಲ್ಲೂ ಕೂಡ potential ಏನಿರುತ್ತೆ ಸೇಮ್ ಏನಾಗುತ್ತೆ ನಮಗೆ ಡಿವೈಡ್ ಆಗುತ್ತೆ, right? So that is potential across cell E1. So across cell E1 we can write V is equals to E1 minus I1 R1, right? So potential across E1 we can write V is equals to E1 minus I1 R1. So first relation ಅಲ್ಲಿ ನಮಗೆ I1 relation ಬರ್ಕೊಂಡಿದೀವಿ. So I1 is equals to E1 minus V divided by R1. So calling this second relation, right? So same wise potential across cell E2. So ಇಲ್ಲಿ ಕೆಲವು ಕಡೆ ಕ್ಯಾಪಿಟಲ್ E ಇದೆ, ಸೊ ಅದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತಾನೂ ಬರುತ್ತೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರನೇ ಇಲ್ಲಿ ಸೆಲ್ಸ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು ಸಿಗ್ಮಾ ಯೂಸ್ ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ, right? So that is epsilon symbol ನ ಯೂಸ್ ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ, that represents what the EMF of the cell, right? So across E2 again the potential is same, so hence we taken V that is equals to E2 minus I2 R2. So from this I2 is equals to E2 minus V divided by R2, called third equation, right? So substitute 2 and 3 in first equation, right? Substitute equation 2 and 3 in equation 1, right? So 2 ಮತ್ತೆ 3 ಎರಡು equation ಯಾವುದಕ್ಕೆ first ಗೆ substitute ಮಾಡಬೇಕು. So I is equal to I1 plus ಅಲ್ಲಿ E1 minus V divided by R1 plus E2 minus V divided by R2. So separate ಮಾಡಿ ಬರ್ಕೊಂಡ್ರೆ E1 by R1 plus E2 by R2. So minus ತೆಗೆದ್ರೆ, so ಎರಡು ಟರ್ಮ್ ಅಲ್ಲಿ minus V ಕಾಮನ್ ತೆಗೆದ್ರೆ 1 by R1 plus 1 by R2, right? So RHS ಅಲ್ಲಿ LCM ತಗೊಂಡ್ರೆ, right, I that is equals to E1 R2 plus E2 R1 divided by R1 R2 minus B into R1 plus R2 divided by R1 R2, right? Equation is multiplied by R2 divided by R1 plus R2. So these two whole equation na ನಾವು ಯಾವುದರಿಂದ multiply ಮಾಡಬೇಕು, R1 R2 divided by R1 plus R2, right? So I into R1 R2 divided by R1 plus R2, that is equals to E1 R2 plus E2 R1 divided by R1 plus R2 minus B. So ನಮಗೆ ಏನು ಬೇಕಾಗಿರೋದು B ಬೇಕಾಗಿದೆ, right? So B is equals to E1 R plus 2R1 divided by R1 plus R2 minus I into R1 R2 divided by R1 plus R2. Call this one as fourth relation, right? So now replace this combination of cells with the equivalent cell. So ಇದನ್ನ ಯಾವುದರ ಜೊತೆಗೆ replace ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ which having only the one cell. So that cell is the equivalent cell which having the internal resistance are equivalent, right? So A, C. Here also current flow ಆಗ್ತಾ ಇರೋದು I. So potential across these two combination ಏನಿರುತ್ತೆ V, so that will be the same because current flow ಆಗ್ತಾ ಇರೋದು equivalent cell ಕೂಡ same ಇರುತ್ತೆ, right? So from equivalent EMF, right? So V is equals to E equivalent minus I R equivalent, right? So call this one as the fifth relation, right? So now compare the relation 4 with relation 5, right? Compare equation 4 with 5. So LHS ಅಲ್ಲಿ V asterisk ಇದೆ. So RHS ಅಲ್ಲಿ in place of E equivalent, that is equals to E1 R2 plus E2 R1 divided by R1 plus R2, right? So again I asterisk is there. So in place of R equivalent we have R1 R2 divided by R1 plus R2. So this is the equivalent EMF and internal resistance of a cell when the two cells are connected in parallel, right? So simple is that first we need to consider two cells. So the first cell having the EMF E1 and internal resistance R1, and the second cell E2 and the internal resistance R2, right? So these two are connected in parallel. So current which is flowing in the combination is I. So at the junction, so aduna namings ನೀವು ಇಷ್ಟ ಬಂದಿದೆ ಏನಿದೆ ಅದನ್ನ ಕೊಡಬಹುದು. So at the junction B2, that is again from the Kirchhoff current law, current ಏನಾಗುತ್ತೆ ನಮಗೆ ಡಿವೈಡ್ ಆಗುತ್ತೆ. So I becomes I1 plus I2. I1 is the current which is flowing in the cell E1 and I2 is the current which is flowing in the cell E2, right? So I is equals to I1 plus I2. So when the cells are connected in parallel, the potential across the first cell is equals to the potential across the second cell. So potential ಏನಿರುತ್ತೆ ನಮಗೆ same ಇರುತ್ತೆ. So hence first we need to find the potential across the first, right? So potential across the cell E1, that is equals to V is equals to E1, that is sigma 1 minus IR1, right? So from that ನಮಗೆ ಇಲ್ಲಿ ಏನು ಬೇಕಾಗಿದೆ I1 ಮತ್ತೆ I2 ಬೇಕಾಗಿದೆ. So from that we need to find the values of I1 and I2 by using the relation V is equals to E minus I1 R1. So ಅದು ನಮಗೆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ರಿಲೇಷನ್ ಇದೆ, ಡಿರೈವ್ ಕೂಡ ಮಾಡಿದೀವಿ. V is equals to E minus IR, where I is the current which is flowing in the circuit and R is the internal resistance and V is the potential applied across the cell, right? So next to mathematical simplification, so rearrange ಮಾಡಿ simplify ಮಾಡಿ ಬರುತ್ತೆ, we get the relation, right? So this two parallel ಆಯ್ತು. So next in series, right? So in that second one is series, right? So consider cell E1 internal resistance R1, so potential that is across A B. So V is the potential across AB, that is VAB, and connect one more cell which having EMF E2, so that is B and C. So I is the current which is flowing in the combination, right? So I ಏನಿದೆ ನಮಗೆ series ಅಲ್ಲಿ divide ಆಗೋದಿಲ್ಲ. So potential ಅಷ್ಟೇ. So here the potential is VAB, right? So here the potential is VBC, right? So right potential at cell E1, right? So VAB, that is equals to VA minus VB, that is equals to E1 minus I R1. So current same irodrinda we can write E1 minus I R1, right? So potential across the cell E2, so that is VBC, that is equals to VB minus VC, that is equals to E2 minus I R2. We need the potential overall combination. So series combination ಅಲ್ಲಿ overall potential ಎಲ್ಲಿಬೇಕು ನಮಗೆ between the B and C. So potential between B and C, right? So potential between B and C. So that is B, not B and C, that is A and C. Potential between A and C. So that is VAC, right? So VAC we can write VA minus VC, right? So add and subtract the term VB, that is minus VB plus VB minus VC. So minus VB plus VB we cancel, again we getting VA minus VC, right? So VA minus VB. So then the VA minus VB we can write that one as E1 minus I R1, right? So same wise VB minus VC iduna ಏನು ಬರ್ಕೋಬಹುದು ನಾವು plus E2 minus I R1, right? So rearranging E1 plus E2 minus I common tagidre R1 plus R2. So this is the potential across the VAC, right? So calling this as first, second. So here from equation 1 and 2 we can write like that. So third equation. Now replace this entire combination with the equivalent EMF. So E equivalent, it has the internal resistance R equivalent, it is connected between the points A and C. Again I is the current which is flowing in the circuit, right? For equivalent EMF, right? So VAC, that is equals to E equivalent minus I R equivalent. So call this one as the fourth relation, right? So compare equation 3 with 4. So LHS ಅಲ್ಲಿ VAC ಇದೆ, LHS ಅಲ್ಲಿ ಕೂಡ VAC ಇದೆ, ಎರಡು ಸೇಮ್ ಇದೆ, right? So come to RHS. So RHS ಅಲ್ಲಿ in place of E equivalent we have, so compare equation 3 and 4. So comparing equation 3 and 4, so E equivalent, that is equals to E1 plus E2. So I as is there, so in place of R equivalent we have an R1 plus R2, right? So this is about the equivalent EMF and equivalent resistance. So equivalent ಅಂತನಾದರೂ ಕರೆಯಬಹುದು ಅಥವಾ ಅಂತನಾದರೂ ಕರೆಯಬಹುದು, right? So this is the combination in series, then this is the equivalent EMF, right? Right. So move on to the next question. Deduce the condition for the balance of Wheatstone using Kirchhoff law, right? So that is we using Kirchhoff's current law and also Kirchhoff's voltage law. So question number 6, right? Wheatstone bridge, right? So Wheatstone bridge consists of 4 resistance, right? So 4 resistance R1, R2, R3, R4, right? So these arms are named as A, B, C, D, right? So the opposite diagonal side connects one galvanometer, so it has the resistance G, or we consider that one as RG, right? So and again the another opposite diagonals are connected to the external source, that is potential. So potential I is the current which is flowing in the circuit, right? So from Kirchhoff's current law at junction A, or node A, so I is equals to I1 plus I2, right? So current ಏನಾಗ್ತದೆ ನಮಗೆ ಡಿವೈಡ್ ಆಗ್ತದೆ the junction A. So I1 is flowing in the circuit R1, and I2 is the current which is flowing in the circuit R2, right? So and also IG is the current which is flowing in the galvanometer. So galvanometer ಅಲ್ಲಿ flow ಆಗ್ತಿರೋ current ನ IG ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, right? So at junction B, so at junction B, current entering into the junction B, that is I1, so current leaving, that is IG. So here we can take I3 current and also here I4 current, right? So I1 is equals to IG plus I3, so from that we can write equals to I1 minus IG, right? So at junction D, IG plus I2, that is equals to I4, right? So now we can take sign convention, right? So one ನೆನಪಿಟ್ಕೋಬೇಕು, ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರೋ ಡೈರೆಕ್ಷನ್ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇರೋ ಡೈರೆಕ್ಷನ್ ಎರಡು ಸೇಮ್ ಇತ್ತು ಅಂದ್ರೆ ಐಆರ್ ಪ್ರಾಡಕ್ಟ್ ಯಾವ್ದ್ರಲ್ಲಿ ಇರುತ್ತೆ, ಯಾವಾಗಲೂ ಮೈನಸ್ ಅಲ್ಲೇ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ಅಪ್ಲೈಂಗ್ Kirchhoff voltage law for the mesh A, B, D, A, right? So A, B, B, A. So our mesh ke ಏನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ನಾವು Kirchhoff voltage law, right? So that is minus I1 R1 minus IG into G. So G is the galvanometer resistance plus I2 R2, that is equals to 0. All the first relation. So next, apply Kirchhoff voltage law for the mesh B, D, C, B, right? So again minus IG, G minus I4, R4 plus I3, R3, that is equals to 0. Right? So I3 ಮತ್ತು I4 ಇದೆ, so substitute the values IG into G minus I4 get I2 plus IG into R4 plus I3, that is I1 minus IG into R3, that is equals to 0. All this one is the second relation, right? So balanced condition for Wheatstone bridge, right? So balanced condition for the Wheatstone bridge, that is current through the galvanometer is 0, right? So IG is equals to 0, then equation 1 and 2 becomes, right? So IG ಎಲ್ಲೆಲ್ಲಿರುತ್ತೋ ಅಲ್ಲೆಲ್ಲ 0 substitute ಮಾಡಿ, so 0 into G, it becomes 0, so that becomes minus I1 R1 plus I2 R2, that is equals to 0. So I1 R1 is equals to I2 R2, right? So I2 by I1, that is equals to R1 by R2. All this one is the third relation, right? So same wise in the second relation also IG is IG is 0, so here also IG is 0, here also IG 0. So remaining is minus I2 R4 plus I1 R3, that is equals to 0. I2 R4, that is equals to I1 R3, I2 by I1, that is equals to R3 by R4, right? Following fourth relation. So from equation 3 and 4, LHS ratios I2 by I1, here also I2 by I1 is there, right? So from equation 3 and 4, from equation 3 and 4, so LHS ಅಲ್ಲಿ ಎರಡು ಟರ್ಮ್ಸ್ ಸೇಮ್ ಇರೋದ್ರಿಂದ R1 by R2 that is equals to R3 by R4. So this is the balance condition for the Wheatstone bridge, right? So condition for the balanced Wheatstone bridge using Kirchhoff rule. So using Kirchhoff rules ಅಂತ ಹೇಳಿದ್ರೆ we need to mention Kirchhoff's current law ದಲ್ಲಿ ಎಷ್ಟು ಬರುತ್ತೆ, ಈ 3 ಬರುತ್ತೆ, ಅದನ್ನ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. Then Kirchhoff voltage law ಅಲ್ಲಿ 2 ಬರುತ್ತೆ, ಇವೆರಡನ್ನು ಕೂಡ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು, right? So using Kirchhoff law ಇರೋದ್ರಿಂದ we need to use these laws, right? So in the next class we will discuss remaining questions, right? Thank you.